10, teacher.
Nice. How many volts have we got supplying this circuit?
25, teacher.
Good job. Thank you. Well done, mate. Nice one. Good. Okay. So what we want to do, simply add all these together. So 10 plus 5 is 10 plus 15 is, you can do it on your calculator if you want. 10 plus 15, ally?
25.
Good. Plus 22, ally?
47.
Good. Plus 82, ally?
Wait. 129.
Fine. Good job. Okay. So we have a total resistance total of 129 ohms, okay? Now we want to find our current total, okay? So what we're going to do is use Ohm's law. We're going to use, to find our current total, to find current, what do we do? According to Ohm's law, to find current, what do we do?
Get the voltage divided by R.
Voltage divided by
resistance.
Yeah, good. Okay, we know our voltage supply, Vs, voltage supply is 25 volts, yeah? And our resistance total is 129 ohms. So if we ping this into our calculator, so 25, divided by 129, we have the value down here, look. As we rounded it up, 194.
104 milliamps.
94 milliamp.
Good job. Well done. Sweet. Nice. Calculate mine?
Understood.
Calculate. Nice and easy, yeah? That's simple. Now, find the VS, so find the voltage supply if current is 1 milliamp. Let's move down here. So we know here we have 1 milliamp, where our little A is, yeah? So RT, resistance total. We need to find out our resistance total. So we need to add R1, R2, R3, R4 together. So if we ping the calculator out, say, and we go 1.2 plus 5.6 plus 1.2 plus 1.5. Well, it gives us that. I've put it in the wrong calculator, don't worry. Obviously, our result is 9.5 kilo ohms, okay? Because they're all at K ohms, so kilo ohms. So that's our resistance total, 9.5 kilo ohms. Now to find our voltage supply, we go back to Ohm's law. So according to Ohm's law, how do we find voltage?
Currents time with the resistor.
Nice, good job, well done. Okay, let's ask Pum, are you there? Song. Number 2. Are you there, mate? Pum?
Yeah.
All right, how do we find voltage? What do we do to find voltage?
I multiply R.
Good. What does I mean?
I can't remember it.
Current, yeah, multiplied R. Can you remember R?
Yeah.
Measured in ohms. What's the word?
I can remember this.
Resistance, yeah? Current times resistance will give us the voltage. Okay, Pum. Thank you. All right. So we want to find our voltage supply. So we get our current total times our resistance total. We know here, who can tell me what our current is in this circuit?
1 milliamp.
Good job. 1 minute. Okay, good. Okay, it's quiet now. Yes, so we have 1 milliamp in our circuit. So we do current times resistance total. Teacher?
Okay.
Teacher, can you put your microphone on mute, please?
Okay, I'm close it.
Okay, thank you, thank you. Okay, cool. So we know we have 1 milliamp is our current in this circuit. So we multiply that by our resistance total, 9.5 kilo ohms. And then the answer is, Ally?
9.5 volt.
Good. So our VS, our voltage supply, has been calculated as 9.5 volts. Kajamai, everyone?
Understood, comrade. Understood.
Understood. Good. It's easier when your Thai teacher teaches you in Thai, because then you know sort of what you're looking at, which is good. Right, let's get Boggy.
Yeah,
Hey, Boggy.
Sure.
Can
hello, I'm
you-
here.
Oh, good, good, good. Can you read this for me? Okay, calculate.
Calculate the voltage across
Each.
each resistor and value of VS.
Good job. Well done, mate. Perfect. Good, 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 good.
Okay.
Very good, as you say.
Yeah, very good, very good.
Very good. All right, good. So we're going to calculate the voltage across each resistor. So between the resistors here, R1, R2, R3, we are going to calculate the voltage, okay? And then get the value VS. It will be our VS. So let's move down to here. So first of all, we are going to start this side with resistor 1. So to find our voltage through resistor 1, what we have to do is get our current total, which is 2 milliamp, and multiply it by R1. Okay, here. So what we'll do, we have 2 milliamp. Multiply that by 1, and that gives us a value of
Volt.
good 2 volts, yeah?
2 volt.
So we can say between this resistor, we have 2 volts. Now we're going to do resistor 2. See how the value changes. What is the resistance value in R2?
Is a 4. It's a 4, right? It's a 2 kilo ohm there.
2 kilo ohms, good. So the value of resistance in R2 is 2 kilo ohms. So we get our current total, which is 2 milliamp. Again, multiplied by R2, so the resistance, which is 2. 2 times 2 is
4.
4. So we got 2 milliamp multiplied by 2
kilo.
Yep, kilo ohms. And then that will give us 4 volts. So we have 2 volts between R1, 4 volts between R2. Now we're going to look at R3. So we get our current total again, which is 2 milliamp. And we times it by resistance, which is 3 kilo ohms. Okay? So obviously voltage, we do current times resistance. Ohm's law again, nice and simple. So 2 times 3 is
6.
good. So 2 milliamp multiplied by 3 kilo ohm, we'll work out as 6 volts. So we have 2 volts between R1, and then we have 4 volts between R2, and then we have 6 volts between R3. So that gives us a value of how many volts for our VS?
We got 12 volt.
12, yeah? Because we're going to plus these together. Nice. So 2 plus 4 is 6. We know 6 add 6 is 12. Good. Nice. Kaljai everyone.
Got it.
Right, okay, so we've got this file. Yeah. So we got our resistance total of 6 kilo ohms when we add this. And then our voltage supply, as we have done, we're going to work it out as current times resistance total. 2 milliamp times 6 kilo ohms also gives us 12 volts. Okay? So all we've done is added them together, really. But then this is the different way to do it. Okay, so we go back. We have figured out if we plus all of these together, 2, 4, and then 6, we're going to come up with the voltage supply, which is under Kirchhoff's law, which we're going to learn about in a minute. Voltage sources in series. This is a torch. Okay. These are our batteries. Let's say they're AA batteries. Okay. Let's go, where we at? PMI, you there? PMI. PMI sleeping, yeah? Okay, knee. Knee. Number 8.
Yeah, teacher.
Hey. Okay. How many volts is one battery feeding? So we have 3 batteries here. 1, 2, 3. Now we look on our schematic on the right. One battery is
ให้ตอบ
ว่ามันมีค่าเท่าไหร่
1.5 volt.
Good job. So 2 batteries together are supplying
ให้ตอบค่าเหรอ
เอามารวมกันได้เท่าไหร่2ตัว
3 volt.
Nice, good job. So then 3, 1, 2, 3 batteries will supply
4.5 volt.
Nice, good job. Thank you, Nate. Perfect. Well done. Good. I'm just going to put the aircon on. I've been hot.
Are you by the way?
ว่าใครกู
That's better. Okay. So now this is how we're going to measure how many volts our battery is feeding. We've done this with teacher Aris on Saturday. We tested the 9-volt battery. This is same. So we'll put our positive on a positive, negative on our negative. if it's a 1.5 volt battery, we should get a reading of 1.5 volts. Okay? Nice and simple. Now we have two batteries, two 1.5 volts. If we add these together, 1.5, add 1.5, we get, hello?
3 volt.
3 volts, nice, good job. Nice and easy there. To get your voltage, you do voltage battery 1, voltage plus battery 2, gives you 3 volts, nice and easy, yeah? So we have 3 batteries here, and as Ni said, they all equaled 4.5 volts, 4.5 volts. So when we test between all of them, our reading here should be 4.5 volts. And obviously we put it on the 20 setting. Remember? Because it's between 2 and 20. It's in between. Okay, nice and easy, guys. Really easy that. Add the batteries together. So simple. Same. So this is how we. 1.5. So this is what we want to do here: is find the value for this. Would be 1.5 volts. Now we're going to come down to Kirchhoff's voltage law, KVL. Okay. Ford.
Oh, good.
Number 10, you there?
Okay.
Okay, buddy. Can you read all of this?
Kirchhoff voltage law is a fundamental circuit law that algebraic, right?
Yeah.
Sum of all the voltage around a single closed path is 0, or in other words, the sum of the voltage drop equal the total source voltage.
Good job. Nice one. So it's basically saying between each resistor, you'll have the voltage, and then that'll all add up to give you your VS, voltage supply. Let's have a look now. Okay. So the sum of all the voltage drops around a single closed path in a circuit is equal to the total source voltage in that closed path. Okay. So our voltage drop between V1, V2, V3 will add up to 12 volts, our VS. Okay. That's Kirchhoff's law. So we're going to look at this. VS equals V1, V2 plus V3, on and on and on, plus Vn. And that gives us our voltage supply. Cao Jai Mai? Nice and easy?
Yeah.
Yes.
Okay. Kirchhoff's voltage law was made here for a series circuit, but the concept can be applied to any circuit. Okay? So here we have 12 volt supply between, let's say this is R1 here, we get a reading of 6.6 volt drop. Okay, so we can do this on our calculator, so I can do it on the screen actually, it'd be better. 6.6 plus 5.4, ally. 6 plus 6, 5 plus 4 is
10 volt. Yeah, 5, 4.
12 volts.
Thank you. Who said 12? Who said 10 first?
Okay.
All right, good. We got there in the end. Nice.
Oh shit,
12
this
volts.
is coming.
So I've got something a little bit here. Yeah, nice and simple. So we got 87 volt supply So between these resistors, it should all add up, the volt drop, to 87, right? Does that make sense? Cadre mine?
Yeah.
Yeah. So the voltage between each resistor will add up to a zero value. And the zero value will be 87 because that's the VS, voltage supply. So if I hit the play button now, please be right. This is where it goes wrong. So if we now add these numbers together, hopefully 13.076 plus 21.458 plus 24.303 plus 28.163. What's the answer?
85, 87.
87, yeah?
Yeah.
Let's hope 87. Yeah, good. Okay, 87. Nice. So we know between, if that's how we want to find our voltage supply, turn it on, test between each voltage, between each resistor, and then you'll have your voltage supply. Nice and easy. Okay. So now let's do this. Delete that like that. We'll come back to this. It's nice and easy there. To find our voltage supply, add it all together. Our volt drop between each resistor. We're going to say our supply really you could count as zero because we're trying to find our zero factor, which will be the supply number, if that makes sense. That's quite confusing. Anyway, now we're going to look at this here. So our voltage supply plus V1 plus V2 plus V3. Yeah, we got 2 volts, 4 volts, 6 volts between each resistor. So let me say that slowly. Between resistor 1, we have a volt drop of 2 volts. Between resistor 2, a volt drop of 4 volts. And 3, drop of 6 volts. Our supply voltage is, ally? 12 volts, nice. So we're just going to do Vs plus V1 plus V2 plus V3, yeah? And it equals 0. But in this case, if we minus, so if we use our calculator here, easiest way to find it out, well, just do minus 12, then add 2, 4, and 6. 6 add 4, add 2 is 12. Add, yeah, minus 12, add 12 will bring us to 0.
Yo.
Yeah. So in that case, then we know what our supply voltage is. Nice and easy. So here, we're going to determine the source of voltage. The answers are coming up straight away because I'm not using it properly. But we would do a voltage supply would be 5 volts plus 10 volts is 15 volts. And that's our voltage supply. Can't I?
Yes.
Right. By Kirchhoff's law, we've just done this. V1 plus V2 plus V3 equals our voltage supply. Nice and easy. Okay. So we can say V3 because we're going to look for our voltage drop between our resistor 3. We could say Vs So a voltage supply minus V1 minus V2. So 50 volts on our VS, minus the 12, minus the 25, and we need to add this to 50. How many volts do we have left to get to 50?
13
30.
left.
13 volts, yeah, good.
Oh,
Nice. Because what we could do,
lying over here.
now we could go 12. Oh, what am I doing it on my calculator for? Now we got the answer. We could go 12 plus 25 plus 13 should equals 50. So our volt drop between each resistors now add up to our voltage supply. Cao Zhai Mai?
Yes.
Yes, I understand.
Okay, good. So we could do really the same sort of thing for this. Now, if I went like this, just down here, over here, like this. Well, 1 minute, I don't want to do this. So, let's say for now, let's delete this one. Problem. So, oh, forget that. Sorry, forget that. I haven't got time to sort that out. So now we want to find the value of R4. Here we go. So resistor 4. Here we go. First, we use Ohm's law to find the voltage drop across each of the known resistors. So we know resistor 1 has a reading of ice. Are you there?
Yeah.
Okay. Resistor 1. What's our resistance in resistor 1?
100.
100. Good. How about resistor 2?
470.
Nice. Resistor 3?
1000.
1 kilo ohm. Okay, yeah. Good. Let's say 1 kilo ohm. And we need to find R4. So we're going to put our Ohm's law into use again. Okay?
Yep.
So we have our V1. And to find our V1, sorry, we do current multiplied by R1. We know our current is 10 milliamp. So we will do 10 milliamp multiplied by 100 ohm will give us how many volts? Hello.
Bookie.
Anyone?
Oh.
No, 1 volt.
Huh?
1.0 volt.
Okay, good. Yeah, 1, yeah? Good. Nice. Well done, guys. 1.0. Okay, now we're going to find V2. Nice and easy. So we're going to do the same again. To find our voltage, we use Ohm's law, current multiplied by resistance. And we're using 2 for our resistor 2. In this case, 10 milliamp is our current. Resistance is 470. 10 multiplied by 470 is, say, 4.7. And then V3. So we go current times resistance, 10 milliamp. Again, by 1, works out as 10 volts. Okay? So this, we're now using this part of Kirchhoff's law to find the V4. So we have our, let's go like this. Our VS of 50 volts, and then we worked out R1 is 1 volt. The volt drop in R2 is 4.7. Volt drop in R3 is 10 volts. So now We need to get to 50 volts.